Hello and welcome with something new, something more interesting, something more exciting. I'm Professor Dr.Mchem from Dr.Mchem's Institute of Chemistry, University of St. John Sharo. And I'm here again today with something interesting for you people to follow, something which we have been continuing since many days. That is, first I was discussing with you viscosity, and now I have, I jumped to the next section, that is thermodynamic parameters. Now, what are thermodynamic parameters? Of course, the Gibbs free energy, delta GV, the in heat of activation of viscous flow, that is delta HV, and of course the entropy, right, which is denoted by delta SV. So these are the basic three thermodynamic parameters which you are supposed to learn during your study. So today I thought that I should discuss with you heat of activation of viscous flow, so which is denoted by delta HV. Now every polymer, if we are talking about polymer, you are now calculating, or you are following the a polymeric you have made polymeric solutions, and now you are going to calculate the thermodynamic parameters or enthalpy of a polymer. Now you have to understand this thing, that every polymer has its own particular temperature at which it initiates thermodynamic reaction. That is, the reaction is initiated particularly by that polymer, and it is through a typical type of a reaction, right? So what I was saying, that every polymer has its own particular temperature at which it initiates, or you can say it progresses, the thermodynamic reaction. This is something very important and very interesting to note down. And the delta HV, that is the enthalpy for monomer and polymers, can be calculated by the equation, that is delta G equals to 2.303 RT log of eta absolute over 10 raised to power minus 3. Now this is a general equation from which you can calculate delta G easily, right, for the monomers, for the monomeric compounds, and as well as for the polymeric compounds, right? Now I hope everyone knows what is a monomer and what a polymer, because I've been discussing these monomers and these polymers since since my last 4 lectures. Okay, now when and a linear relationship was obtained when this delta HV was calculated between log of eta, that is absolute viscosity, over 1 over T, and you got a straight line, and we have calculated the slope, that is delta HV over R, right? So enthalpy of activation of viscous flow of a monomer and a polymer was calculated, and the results showed that the enthalpy of the monomers were, the values of enthalpy of monomers were increased as compared to the polymeric compounds, right? As for example, if the monomers, they were exhibiting almost the values starting at different concentration, that is starting from 0.024, 0.034, 0.044, 0.054, and 0.064 grams per deciliter. These were the different concentrations which were suggested for these polymeric and monomer compounds. So the monomers, they presented the higher values as compared to the polymers, right? For example, the monomers, they were having 14.535 at 0.024 grams per deciliter, whereas at about 0.034 it was about 14.86, and so on. Whereas polymers, they started from 11.001, 11.010, 10.111, and 10.122. That means that their enthalpy values were less as compared to the monomer, right? And what is the reason behind that? I will tell you the reason right now. Okay, so the values of enthalpy for the monomers were higher as compared to the polymers was due to one basic reason. It is because as the process of degradation, that is, or you can say the process of degradation of is reduced in the long chain macromolecules. So this could be one of the reasons that when polymers have the long chain, they are of course they have a longer, they have the bulkier as compared to the monomers, right? So monomer is a single unit, so this is the process why it's, and the values of delta HV are positive initiating process of deprivation of the structure and orientation of macromolecules occur during the flow process. This is one of the reasons.